Let's continue from chapter 8, 1851 chip pin configuration. Yes, for the standard 1851, we have 40 pins. Let's examine in detail. From 1 to 8, we have port 1. Okay, port 1. And 9, we have reset pin. 10 to 17, we have port 3. But in here we have some differences between the port 1, as you see. In here we have some the other alternative function for the ports. Okay. As you know, ports are used for the communication between the microcontroller and physical world, but we need some the other specification, and we need some the other some pins to do this. But in here we have only 40 pins, so some pins are used with another functions. Okay. And 18 and 19, we have oscillator connection pins, and 20 means ground, and 40 means supply voltage, and 21 to 28 we have port 2, and again we have some the other alternative functions here. 29 to 31, these pins are used for the access external memory, and 32 to 39 we have port 0, and as you see again we have some the other function for these ports. We will learn all of these pins in this lecture in detail. This is the real-time photograph for the standard 1851. Yes, supply voltage, as you know, for the 1851, the ground pin 20 and supply voltage is provided from the 40 number pins. Yes, reset. Reset pins is used for the stable operation of the microcontroller, and to do this we need some necessities. In this figure we can explain. Yes, in here we have supply voltage, and as you see 40 pins fed from this voltage, and also EA pins supplied this voltage. It means external access. So we know this. If this pin is 1, we will use internal memory, internal program memory. Okay, let's continue. In here we have another way, and we have a resistor and capacitor here, and also a button. Please continue in this road, and we have another resistor and ground, and this connection for the reset pin. How can we do it with this connection? If you press this button, your current will be follow this road, and in here we have 5 volt approximately, not exactly, because as you see in here a voltage divider between the 100 ohm and 8.2 kilo ohm. So we have a voltage divider here, so we can say in this node we have approximately 5 volts. It means logic 1 for us. Okay, so we can do reset operation by using this hardware. What about the other? In xtol 1 and xtol 2, we need to connect a crystal for the clock pulses and also two capacitor between the ground and crystal. And the last one, in number 20, we have ground pin. In order to do a proper reset operation, we need to this pin at least 2 machine cycle at logic 1. Okay. In here we have a shape. In here we have a capacitor. It means we have to prevent parasitic operation. Okay. According to this circuit, we will have this kind of the time between these 2 points is important for the reset operation. T2 minus T1 must be at least 2 machine cycle. What is machine cycle? We don't know yet, but you can understand this. Machine cycle means some time, but we don't know exactly what is mean. Okay, we will learn in the timer units, timer chapter. But we have to know this. After a valid reset operation, stack pointer start from the 07 hex. Program counter value will be 00 hex and all ports will be FFX. What about the oscillator inputs? As I said before, clock pulse is thought as heartbeats for the microcontroller. So we need to connect a capacitor, crystal here, and also two capacitor. This is about it. For the external memory access pin, we talked about before. EA pin should be 1 for the internal memory, internal program memory. But if you do 0, so it means you will use external program memory. And the other of them, not important for now. Yes, input and output pins. For the communication between the physical world, we used ports, as you know. And in this chapter, we will learn in detail port structure. We have 4 ports, as you know, and each of them 8-bit and can be operated independently from each other. And after the reset, all ports value will be FFX or all pins will be 1. Yes, let's start from the port 1. Port 1 built-in pull-up resistor and has no additional function other than I/O. So we can use this port only for the I/O. Okay, input or output. And here we have a electrical description for a pin of the port 1. Okay, so this structure should be for all pins of the port 1. For example, it can be port 1.0. Here we have a separated area, and this area micro external world, it's mean physical world for us, and the other area micro internal world. Okay, microcontroller world. And in here we have a buffer here and here, a D-type flip-flop, internal line, clock pulses, and switching device, pull-up resistor. In here we have a supply voltage, and the external world. In the external world we have pins. So first of all, we have to know something. For example, this buffer means three-state buffer, called as three-state buffer. We have a control input, as you see. If your control input is 0, so you can see at the out of this buffer infinite impedance. Okay, so it means that the input is not important for us. It can be 1 or 0, but not important, because we saw from the output infinite impedance. So if your control input is 1, this is the normal condition for us. X value is 1, y should be 1. X value is 0, y should be 0. Three-state buffer is working as like that. What about the others? In here, as you see, we have two three-state buffer. So at each time, only one of them will be worked. Okay. But how? According to the command, one of these three-state buffer will be enabled. If your command use your pins as destination, okay, destination, so latch will be enabled. But in your command, if you use pin as source, so reading pin activated, enabled. So how it can be possible? Maybe we can give an example for you. But before this, we should understand these terms, giving some example here. Yes. For the pin reading commands, for example, move a px. It means px value is loaded to the accumulator. In this command, is there any modification on the px? No. So this is only reading operation. So we can say px is source in this command. What about the other? Jump if not bit. Jump if not bit. Check the px point y value, and if this pin is equal to 0, your program will go to the address value. In this usage, we know this px point y is not changed. So in this usage, we can say this pin is source operand, not destination operand again. What about the other? Jump if bit, port x point y, and address. So check this value, port x point y is equal to 1. Your program will go to the address, and we can say again, in this command, port x point y is not changed. So in here, port x point y is source operand. And the last one, move c port x point y. Again, port x point y is source operand here. What about the other? The other mode operate the latch buffer. Okay, and in this mode we know this ports or pins are destination operand, not source operand. For example, in this command, a and l port x a, it means that read the port x value and do AND operation with the a. and the result will be loaded to the port X. Okay, so we can say in this command port X value, first of all reading and then loading some values. So in here we have some modification. So in here destination operand, and the other then the other logic command can be evaluated as like that. What about the other? In here we have an unconditional branching command. Actually we have here also, but in here we have a difference between them. For example, port X point Y is equal to 1. Your program will go to the address, but before it, port X point Y should be cleared. Okay, so in this command, port X point Y can be changed. Because of this, we can evaluate this command as destination operand. Okay, this being evaluated as destination operand. Yes, and in here you can see already, because port value is directly changed, and in this command first of all decrease port X value, so it's mean change the port X value. So in here again destination operand, and clear and set we can say destination operand. Okay, let's continue from here again. We can give an example, for example here. For example, set bit port 1.0. It means this pin should be 1. Okay, how can we do it? In this usage, destination, because some modification on it. Actually, we changed the port 1.0 value. So in here, destination, we will use latch buffer. It means in here we have 1, but in here we have 0. It means this road is disabled now. What will be happen now? Set bit means internal line will be 1. Okay, the input of the D-type flip-flop will be 1. So we know from the logic circuits Q will be 1. So complement output will be 0. It means in the base of the switching device is 0. It means this is open circuit. Turn off. What will be pin value? In here we have a source and pin value will be 1. For example, if you do clear port 1.0 in this usage, again port 1.0 is destination. So what will be happen now? Please follow all of these operations. Internal line we have 0. It means Q will be 0 and Q prime will be 1. Now this switching device is turned on as like that. So the pin value now will be 0. Okay, actually we like it. We want to do this. What about the other usage as a source? For example, move C port 1.0. For this command, as you see, port 1.0 is source operand. So read pin value. This latch, this control input will be 0. So this road will be disabled. Okay. What will be happen now? read pin control input will be 1, and reading this pin value from the physical world, as you see, and this information is sent to the internal line and microcontroller. That's all. Okay, I hope you understand this. Okay, if you connect 8 of them, you will get port 1 value as like that. So your command is important for you. In your command, port or pin value can be destination or source. Yes, here we have an example again. Set bit port 1.2. If you connect a LED to this pin, what will be happen? The input will be 1, this road will be disabled, and this will be 1. Q will be 1, 0. It means open circuit. So the current will follow this road and turn on the LED. That's all. Maybe you can think about the how can we control the buffer and as like that. It is not important for you actually, because all of this operation will be done by the control unit. Okay, not from us. Control unit can do these operations. And in here, reading latch or reading pin examples, you can check this. Let's continue from port 0. Port 0 is different the other ports, because this port is open drain structure and used for the external memory access, carry low byte of your address value. Okay, the other function of the port 0, besides the communication between the physical world and microcontroller, we can use this port for the carrying address low byte. Okay, in here we can understand easily. As you see, we have some differences according to the port 1. In this area is difference according to the port 1. Okay, maybe I can explain to you. If you use this port for the address value, carrying address value, this control input value will be 1. Okay, and address value should be 0 or 1, we don't know, but we know this. In here we have a multiplexer, and as you know, multiplexer is select the input value which is going to output. So if your control input is 1, multiplexer will be like that. For example, your address bit is 0. Okay, it means that we have an AND gate here and inputs are 0 and 1. The output will be 0. Okay, it means this switching device turn off, as you see, and the output of the inverter we have 1, and follow this road. In here we have 1. It means turn on this switching device, your pin will be 0. Okay, so carry the address value as like that. For example, your address value may be 1, right? It can be. What will be happen now? let's examine. Control input 1, it means MUX will be as like that, and both of the inputs are 1, so the output will be 1. So your switching device is turned on now. Address value is 0 here, and this switching device turned off now. Your port 0.x will be 1, and we want to send already 1 value. Okay, so we can do this operation as like that. What about the other function? Actually, main function. It's main communication between the physical world. So the control input will be 0. It means your multiplexer is like that. So not important for this value for us. If your control input 0, the output of the AND gate will be 0. Turn off this switching device. Now we need to data value in this point. For example, you used set bit 0.x. We don't know. It can be 0, 1, 2, 7. For this usage, we know this. Latch control input will be 1. So this road will be disabled. And in here we have, 1. The output of the D-type flip-flop will be 1. The complement of this, 0. And now, for 0 input, 0 base, the switching device turn off again. What do you think about now port 0.x value? None of them, because we don't know. It can be 0 or 1. It means that we cannot use this port or pin as output. Okay, this is important because we don't have pull-up resistor. If you have pull-up resistor, for example in here, maybe we can VCC R pull-up resistor. Now we can say the pin value is now 1 because this is open circuit, and if you connect a multimeter here, you can measure the VCC value. It means logic 1. Okay. But if you don't use pull-up resistor here, you cannot use this pin as output. Okay. This is important for us. Yes, if you use all pins of the port 0 as output, you have to use pull-up resistor as like that for each pins. Yes, the other port is port 2, and port 2 has a structure as like that. Used for this port is used for the external memory access and also I/O operation. Carry the high byte of the memory address value, and please remember that low byte is carry by the port 0, and high byte of the address value is carry by the port 2. Okay. So this port has a structure as like that, but in here this is pull-up resistor. Okay, you can add this because port 2 has the internal pull-up resistor. Okay, so you can use this port as output without connecting another pull-up resistor. What about the port 3? Port 3 has the other alternative functions. For example, port 3.0 serial communication data input pin. Port 3.1 serial communication data output pin, and blah blah as like that. We will use after, and has like that structure. Internal pull-up resistor is used in the structure of the port 3, so you can use as output, and that's all. Yes, this is the minimum connection required for the 1851 microcontroller. We need a reset input, crystal and some capacitors, ground, supply voltage, and external access pin communication. It can be 0 or 1. Okay, this is minimum connection for the microcontroller or 1851. And in this figure you can see another specification. This is our microcontroller. As you see, for the port 1 we have another alternative function. Actually, in the standard 1851 we don't have these alternative functions. We have one more timer or counter units, so these two pins is related with the timer or counter units, and the other 4 pins is about the SPI communication. In standard 1851 we don't have SPI communication. And the other photograph of the real time our microcontroller.